Hello everyone, hope you are doing good. Before we start understanding of Azure Virtual Network, let us understand some basic concepts of networking. If you are from CCNA background, you can skip this as I will not talk anything new which you are not aware. I know how hard it is to study and clear CCNA exam. So if you are coming from CCNA background, you can skip this. Like any other industry, we have a model for networking also. For example, let us take insurance industry. We have a framework for insurance, and for healthcare, there is a framework, and for banking, there is a separate framework which has been defined by somebody. Similar way, we have ISO OSI model which has been defined for networking industry. Networking industry has to adhere to this model in order to develop any kind of products, whatever they are going to release in the market. So basically, ISO is a body which is a vendor neutral body which creates the guidelines and standards for the networking industry to follow. And the networking industry, which comes under the ISO, has to follow these guidelines whenever they release any products into the market. The products can be a NIC card, switches, routers, cables, and connectors. These are the products which will be manufactured by the vendor and it will be released into the market. So all these products, whatever the networking industry manufactures and releases to the market, they have to adhere to the standards. So let us understand about ISO OSI model and TCP IP model at an eye level. At the layer 7, we have the physical layer. So physical layer is all about the cables and connectors. And at the layer 6, we have the data link layer. At the data link layer, we have the Ethernet frames checked. If the frames matched, then it will be picked up for the above layer. Otherwise, it will be dropped to the physical layer. In the layer number 5, we have network layer. This network layer is where the IP protocol works. IP, IPX, all this protocol works at this network layer. At layer number 4, we have the transport layer. Transport layer is the one which takes care of connectionless and connection oriented protocols. We have TCP and UDP working in layer number 4. And layer number 3, we have the session layer. Session layer is basically to maintain the session between two connections. At layer number 2, we have the presentation layer. At this layer, the encryption, decryption, compression, decompression, everything will be taken care. At layer 1, we have the application layer. So whatever the data which has come from physical layer till the presentation layer, the application layer is the one which processes the data. Protocols for application layers are HTTP, HTTPS, IMAP, POP3, and SMTP are some of the protocols which will be working at application layer. In TCP/IP model, some of the layers has been consolidated or condensed. Eventually, whenever there is a data flow which will happen from the source to the target, whenever there is a data flow which will happen from the source to the target or target to the source, the data flow sequence will be like this. So the data has to flow from physical layer, which is basically it has to flow in terms of bits at the physical layer, and it moves to the data link layer, then it will move to the network layer, transport layer, then session layer, then presentation layer, eventually at application layer. After this, there will be a user who will be accessing the application. So now user has received the mail and he has opened the mail and checked it. If the user wanted to write a mail and send it to the other computer or other user, so this is another user to which the user wanted to send a mail, the same flow will happen to the data, but in the reverse sequence. The user will be sending the mail from the application layer to the physical layer, and once the data comes to the physical layer, it will be converted into bits and bytes. So all the data will be transmitted into bits and bytes, because at the physical layer you have the cables and connectors, and the data will be carried using bits and bytes, and it will be sent to the another user, and the data flow sequence will happen from the physical layer to the application layer for this particular user. This is a very high level overview of ISO OSI model. At each OSI model, at each layer of the OSI model, basically there are multiple protocols which will be working. Let us understand the ISO OSI model with a diagram. If I take this one as one computer and this is another computer, whenever there is a data packets which are sent from one computer to another computer, there will be a transmit or there will be a receive which will happen, TX and RX. If you think that we need to have some protocol to be used for communication like TCP/IP protocol, and TCP/IP protocol is not a single protocol. TCP is one set of protocol which will be working at transport layer, and IP is another protocol which will be working at network layer. So just to take you back to Windows 95, which was released during 1995, there was also a protocol which was called NetBEUI protocol. NetBEUI protocol can be installed on any of the computers, and the computer on which the NetBEUI protocol is installed, it can communicate between each other without the use of TCP/IP protocol. When we were using workgroup concept with 10 computers, so NetBEUI protocol was sufficient to communicate within 10 computers. If more than 10 computers was in a work group, then we used to have TCP/IP protocol. Even during Windows 95-98 and Windows NT, whenever we wanted to install network interface card and configure the IP address, it was really a pain and it was very difficult to install the NIC card and configure the IP address. So it was a difficult time during Windows 95-98 and Windows NT. After the launch of Windows 2000 and Windows XP, everything became very easy, and installation of NIC card and assigning the IP address was seamless. If I take this computer as computer 1 and computer 2, if there is a connection between these two computers, I can directly connect these two computers without the help of any switch or hub, because if I use the cross cable connection, I can directly connect these two computers with RJ45 connector and Cat5 or Cat6 cable. And for these two computers to communicate, I need to assign the IP address. So I need to assign the IP address which can be in the range of 192.168.0.10, and for this I can assign the IP address with .11. These two IP should be in the range in the same range. Whenever this computer, which is computer number 2, tries to send any data, that data, it will be transmitted from the upper layer to the data link layer. At the data link layer, what exactly happens is you have the NIC card, and you have the NIC card which is going to take the data from the upper layer, which is from the network layer, and make that data into Ethernet frame. So this particular Ethernet frame has 1500 bytes, and it also has source MAC address and the destination MAC address. Because only 2 computers are connected here, the computer 2 knows to which computer it has to send the data to, or the Ethernet frame to. Since the destination MAC address is destined for computer 1, this computer 1 picks up the Ethernet frame, which is of 1500 bytes. It will pick up the Ethernet frame and pass it on to the upper level layer, which is network layer. Because the Ethernet frame at the destination address, so the computer 1 has picked up the Ethernet frame. Now it has to pass on to the next above layer, which is network layer. When you open the network packets, it also contains the source IP address and the destination IP address. Because this computer 1 has an IP address of 192.168.0.10, it understands this particular packet is destined for computer 1. So it will pick up the packet, then it will pass on to the above layer, which is transport layer. From there, the connection oriented or the connection less protocol will start working, like the TCP protocol and UDP protocol will start working at transport layer. Once the transport layer has picked up the network segments, then it will move on to the other layers, which are upper layer, like the session layer and presentation layer and the application layer. So this is how the data which comes as an Ethernet frame will be picked up by the NIC card, and then it will pass on to the above layer till application layer. So we discussed about 2 computers communicating between each other. Now let us see if I have multiple computers which are communicating, and also it needs to connect to the internet. In this example, let us say you have got a wireless router, and this particular wireless router also has something called as inbound and outbound connections. The outbound connection will be the Ethernet connection, which you will be connecting to your ISP network. In most of the wireless devices, what you can see is you have something called as WAN connection, which is wide area network. And for the local area network, which is LAN, you can either have one computer, your own personal computer or laptop, connecting to the internet, or you can also have multiple computers connecting to the wireless device. So I have 4 computers which are connecting via this particular wireless device, wireless router, which the ISP has provided. We know that the NIC card, which has the burned in MAC address, and it also knows the source address and the destination address whenever it creates the frame. So if 2 computers are there, it is very easy to pick up the Ethernet frame, because you have the wireless router which is also acting as a local area switch. This particular switch maintains the table about the switching. This switching table contains the MAC address of all the computers which are connected to this particular wireless router, and It keeps the table about all the MAC address of all the 4 computers and to which port it is connected to. If computer 1 want to talk to computer 4, so it knows to which port it has to send that particular Ethernet frame to. It will simply get the frame and it uses the switching table to check to which port this computer 4 has been connected, and it will transmit that particular Ethernet frame to computer 4. Because this wireless router also acts as switching as well as a routing device, the LAN connection, whatever you have connected, it will be at the layer 2, which is a data link layer. And the connection which is going out of the network, which is out of the router or out of the wireless device, that will be taken care by your network layer. This particular network layer has the public IP address what the ISP has provided. Even though these computers which are connected to the wireless device, wireless router, will get its IP from the wireless device itself. So the wireless router, whatever you are seeing here, it will act as the LAN switch, and also it will provide DHCP server. It will also act as DHCP server by providing IP address to these computers. These computers will be provided with the IP address. These IP address are private IP address, and once any one of the computer wanted to communicate to the outer world, to the internet, basically it has to go via this wireless router, and it will use the public IP to communicate with the internet. This wireless router, which is functioning as a router, as a DHCP server, and also as a LAN switch, it also functions as a NAT device, which is network address translator device. So basically whatever IP address which we are using at the LAN, these IP address are private IP address. For the private IP address to communicate with the public, we need to have something called as NAT. That will be taken care by the router itself. Basically, this NAT device is the one which converts the private IP address and makes the computer to communicate with the public internet. So the router is also functioning as NAT, DHCP server, and local area network, and also it will function as a router as well. So after going through all this, something should have struck into your mind. This particular device is exactly same as virtual network in Azure. So whenever you create a virtual network, and if we assume these are all the virtual machines which are in the virtual network, all these virtual machines has by default outbound network connection to the internet. And also you will be assigned with the DHCP IPs. So this particular virtual network also act as a DHCP server, and that will assign the IP address whatever we have defined for the virtual network, which is private IP address. So the virtual network, when you create, that will act as network address translator, local area network, and also DHCP server. Okay, so this brings to another question. So why we require subnet? Yes, subnet is required because there is something called as collision domain, and broadcast domain. So we break the bigger network into smaller network into subnets. That is why we require subnets. And whatever we see here, these are all software defined network. So now I think it should be clear when you are working on virtual network in Azure. Let's dive into Azure Virtual Network in our next chapters.